Alright hosses, welcome back, and in this tutorial I'm going to show you guys how to use Bitwise Operators in Python. Now just a heads up, it's probably really useful if you guys already know binary. So if you guys don't, then go ahead and watch my networking tutorials. One of the videos in there I explain how to interpret binary. Basically, if you have a value like 1101, 1101, then how to turn this value into an actual number. If you can do that, then you're ready to watch this video. And if not, then I'll talk you guys through it real quick. But, you know, just a heads up. So let's say that we have two different values. So we'll say we have a value A, and this is just equal to the regular number 50, no binary or anything like that. And we have another number B, and this is equal to 25. Well, if you guys remember, the binary of 50, let's see if I can get it. It's what is it? 110010. I think that's it. All right. So the binary of the value 50 is 110010. Now, of course, this place is for the ones. This is for the 2, 4, 8, 16, and 32. All right. That's interesting. But what do we care? Well, if we try to AND it with the value of 25, which is, let's see, 011001. All right. Check it out. So adding these together in normal human language would just give you 75, right? Well, whenever you do a binary AND, you don't add them together in that kind of way. So whenever you have a binary AND, what you're going to do is use the ampersand operator. So A and B. So let me give myself some more space. All right. So what the binary AND does, remember, is it goes through and it puts a 0 unless the top and the bottom are both 1s. So if one of these is a 0 or both of them is a 0, then it gets a 0. So 0 for this one, since this one's a 0, and 1 for this one. Basically, the only time you're going to get a 1 is when both of them are 1s. So this one's a 0, this one's definitely a 0, this one's a 0, and this one's a 0. So that's what it does. It goes through and it ANDs them together. In other words, it finds a result and it only has a 1 when both of those are 1s. So now what we can do is we can print C. And whenever we do that, it will give you 16. So we can verify that by making sure. So 1, 2, 4, 8, 16. And no 32. So that is indeed correct. That's what's going on. Now, let me copy this right there, and all right. So the next thing I want to teach you guys is right shift. And by the way, there's also OR and, you know, a bunch of other stuff, but I figured if you guys know how to do AND, then you guys know how to do OR. Now, one kind of tricky thing is binary right shift, and I'll give you guys an explanation of what the heck this is. So say that you have a variable and it's just equal to human readable 240. That's just the value, and 240 in binary is 11110000. So what we want to do is we actually want to take 240 and right shift it. That means take all these bits and shift them to the right. Now, whenever you do that, the bits on your left are just going to turn to 0. So what we're basically doing is this. We're going to make a new variable called y, and this is going to be equal to x with every bit shifted 2 spots to the right. Now, if you ever want to do left, then just use less than, but let's take this and shift every bit 2 spots to the right. So instead of 11110000, we get 00. Remember, the first one are always zeros. 111100. So now you can see that we're pretty much just taking these bits and shifting them to the right 2 spots. So now what we can do is we can actually print y and check it out. So the original value was 240. However, the value of 00111100, that is indeed 60. And if you want to run that through some online calculator, then you can validate that. But trust me, guys, it is. I wouldn't lie to you. Actually, I would, but but not about this. All right. So there you go. That is how you do binary and in binary rate shift. Yeah, that's all I got to say. All right. See you guys next time.